Welcome dear viewers to my channel Welding Education. Well, in the first part we have discussed about the weldability of chrome moly steel, and we stopped at a discussion of post heating, dehydrogenation treatment and intermediate stress living. Well, these heat treatments have purpose. For example, preheating alone does not bring down the residual stresses. So post-heating and dehydrogenation treatment reduces the stress levels, and intermediate stress leveling reduces the dissolved hydrogen levels, residual stresses and hardness. So three heat treatment processes, post-heating, dehydrogenation treatment in intermediate stress leveling, are very much necessary for a chrome moly steel. So this graph showing the diffusible hydrogel content in milligram per 100 gram of weld deposits versus the various levels of residual stresses and dehydrogenation or the dissolved hydrogen level. Now, reheat cracking is a matter of concern for chrome moly steel. So first, how it is defined? It is defined as a cracking that occurs in the heat affected zone or weld metal during the exposure of welded assembly to post-weld heat treatment or elevated temperature services. So it is also known as PWHT cracking or stress relief cracking, and it is common with the chrome moly steels containing less than 3% chromium. So reheat cracking is a very well-known phenomena with chrome moly steel, and I'll be presenting an entire talk on the reheat cracking with the low-layer steel, and with austenitic steels also reheat cracking is a well-known phenomena. So these are the pictures of reheat cracking. You would clearly literally see a reheat cracking in the heat affected zone, literally cracking pass through, and here the cracking is so severe, right? You could see this is kind of cracking. Now to evaluate the reheat cracking susceptibility, there is a compositional parameters. First parameter is the delta G parameter. The delta G parameter is considering chromium, molybdenum, vanadium, and if the delta G, if the composition of weld metal, weld deposit is uh, value of is greater than delta G is, when we calculate the value is greater than 0, material is considered to be susceptible. There is another parameter, PSR parameter. PSR parameter considers into equation chromium, copper, molybdenum, vanadium, niobium and titanium. If PSR is greater than 0, material is deemed to be susceptible. Then there is a next parameter known as MCF parameter. MCF parameter considers silicon, copper, phosphorus, arsenic, tin and strontium's effect on the cracking susceptibility, and increase in MCF values decrease in rupture ductility as measured by the elongation hot tensile test. So these are the compositional parameter to evaluate the weldability of the reheat cracking. Second phenomenon is a solidification cracking. Solidification cracking, as you could see in the pictures, it is a crack that forms during the solidification of the molten weld pool. So it's also known as the hot cracking, because it is forms immediately after the welding is completed, sometimes during the root pass or during the hot passes or subsequent filling passes. So lack of sufficient feed of hot material into the area of final solidification, right, the crater caking. So when the weld heat source is approaching at the end of the weld joint, the crater formation take place, and this hot metal will not feed the depression that will create, or will not backfill the any kind of crater or cavity. So it's an unfavorable orientation of the final freezing zone relative to the direction of the solidification, because of um, uh, the direction of the solidification and the orientation. So the liquid, whatever the hot metal from the uh, hot metal cannot feed the small crack that forms. So what is the main criteria, or say the main issues like a long freezing range? Whenever the alloy has high freezing range are susceptible to uh, solidification cracking, because in the composition of the uh, long freezing range, high level of carbon, sulfur, phosphorus, if they are presence of low melting point uh, elements, or a range of freezing, they are going to wet the grain boundary, and they are not going to freeze at the temperature the surrounding material freeze. So they wet the grain boundary, forms a liquid films around, and under the cooling stresses or the shrinkage stresses, the grain boundary separates out. And second factor is the bead shape. So high depth to width ratio is also producing sufficient shrinkage stresses or cooling stresses. Then the joint profile or the root condition and thickness mismatch are the factors affecting to solidification cracking. Now there are some classic example of solidification cracking of some welded joints. First pictures belong to double V groove joint. Second is a narrow groove wheel joint. You can see high depth to width ratio. And third is the fillet weld. So this assembly is in high restraint condition, and so you could literally see a crack formation. And this is the hot crack. The crack just forms immediately after the uh, welding operation is over. Now, compositional parameter to evaluate the hot cracking susceptibility, HCS value, is considering sulfur, phosphorus, silicon, nickel divided by manganese, chromium, molybdenum, vanadium effect. So, if the HCS value is less than 4, the susceptibility is low. So, it is a hot cracking susceptibility factor. And second is a UCS. This considers carbon, sulfur, phosphorus, niobium, silicon, manganese. So you could literally see the coefficient of or multiplying factor of the carbon and sulfur and phosphorus and niobium particularly. They are very high values. UCS is a unit of crack sensitivity, and it is suitable for submerged arc welds. This parameter, if the UCS value is less than 10, susceptibility is low. If UCS is greater than 30, susceptibility is high. So this is some compositional parameter to evaluate the hot cracking susceptibility. Now these are my references from AWS Welding Handbook, Grade 91, Alloy Steel by Spark Pro Engineering Services, and Shield as Cow, and Expert Talk by Dr. Saju Albert, International Welding Engineer. Now, hope you have enjoyed my lecture, and for any welding procedure, weldability, filler metal selection, decimeter metal joining related queries, you can write to me on this WhatsApp number 9879332449, and you can write to my email ID purvesh2578@gmail.com, and I'll be more than happy to uh, give you answer or any question related to weldability on this email ID. And you can subscribe to my blog weldingknowledge.co.in to receive email about interesting question answer post and interaction with the industry professional. Thank you for watching my YouTube channel.